Yes, sir. Shall we start?
Okay, we start our class, ma'am.
Yes, sir.
Yeah. Students, kindly submit your assignments. If we give any questions to you, it is for your understanding. We can check that whether you are understanding it or not. So that is why we are giving assignments and MCQ, multiple choice questions at the end. But we receive very few answers from students. Okay. Hereafter, we will post the numbers of the students, those who have submitted the assignment, and we post the students' numbers, those who are not submitted also in the group. Okay. So as it is first time, I am telling you, very few assignments we have received. So that is compulsory. It is to check whether you are understanding, whether you are following it or not. Okay. So we complete the assignment problem. Whenever I ask questions, please type your answer. Still 63 is there. Remaining students are not there. It is 11:19. The time is 11:19. Okay. So I switch the camera. You stay with us. If there is any technical glitches, don't go away from the classroom or meeting. You stay with the meeting. Immediately we will join. We correct our issue and join. So now I switch the camera to solve the problem. Students, can you hear me? Hear my voice? Is it clear? Type your answers in the chat box. Yes, yes, yes. Okay, good. So I have to ensure my phone is working or not. Okay. Now you pin my name. Pin my name. We start with the yesterday last class problem. So this is the problem we have given. We have given. So obtain mathematical model of the mechanical system. So this is the problem. This is the problem. So it has three masses. So it will have three force balance equations. For each mass, one equation we write. Okay. So we need to consider mass by mass. So first mass we have drawn already. First mass we have drawn M1. M1, that is M1 itself will give a force, opposing force, that is FM1. FB1, here you can see B1. B1. So B1 will give a force, and the other component connected with M1 is K1. K1. So K1 will give a opposing force. So FB1, FK1, FM1 are the three forces. You can refer the diagram. No other elements are connected with M1. No other elements are connected. You can see here, M1 is here. With M1, we have B1 and K1. No other elements are connected. Okay. So we have three forces here. Three forces here. That is two component, two forces. One force is by the mass M1 itself will give an opposing force. Okay. So that is, and you can see from the diagram that there is no input force. There is no input here with M1. There is no input force. Okay. So now, please listen. Now, FM1, this is the free body diagram. So that we have, you people are familiar with free body diagram, I think now. And FM1 equal to m1 into d1 d square x1 by dt square. Fm1 equal to m1 into d square x1 by dt square. Okay. And fk1, you can refer the diagram, original diagram. That is, K1 is connected between M1 and M2. M1 and M2. Okay. So it undergoes two displacements. Two displacement. Displacement is the output here. So Fk1 equal to K1 into x1 minus x2. Fk1 equal to K1 into x1 minus x2. So x1 is the, here you please understand, x1 is the displacement associated with m1. Associated, you can refer the diagram. So here it is not given, we need to assume. Whenever the displacements are not given, we have to assume. I have taken the displacement for m1 is x1, displacement for m2 is x2, and displacement for m3 is x3. So here we come back. Fk1 equal to k1 into x1 minus x2. X1 is the displacement associated with m1. X2 is the displacement associated with m2. And fb1 equal to b1 into dx1 by dt. fb1 equal to b1 into dx1 by dt. Because here, refer the original diagram now. Here it is a fixed part. The dash part is connected, one end of the dash part is connected to fixed portion, and the other end is connected to M1. You can see here. Okay? Right. So FB1 equal to B1 into dx1 by dt. Okay. So here, the sum of opposing forces, Fm1 plus Fk1 plus Fb1 equal to applied force. Is there any applied force? Students, you can participate now. You can answer. Is there any applied force with M1? This is my question. I need a quick answer. So I see only very few names frequently. Other people are not at all answering. Suman Ranjit is answering. Joshua answering. You can answer now. Hari Nation, are you there? Gurunathan?
Hari Nation, 110.
Nation is not there. He is not at all responding. Hari Nation. Gurunathan? Okay. So we have, whenever we ask questions, you have to respond so that we can ensure your presence. Okay, it's good. Everybody says no. So you can see now, Fm1 plus Fk1 plus Fp1 equal to 0. As there is no applied force. Is 0. If there is an applied force, the other side, instead of 0, we have to replace the 0 with the applied force. So Fm1 is the opposing force given by the mass m1. Fk1 is the opposing force given by spring k1, and Fb1 is the opposing force given by the dash part p1. Okay. So now we move one step further. You can see now. So now I take out the M2 case. This is okay. Now Fm1 plus Fk1 plus Fp1 equal to 0. This is right. Now you can see now. Just a minute. replace the things. We need to replace the things. Students, can you hear me now? You can answer. Okay, just now I received a call. That's why I'm asking. Okay, I disconnected. Okay, okay. So now we need to replace FM1, FM1, FB1, FK1. So FM1 equal to M1 into D square X1 by dt square plus B1 into dx by dt plus k into x1 minus x2 equal to 0. You can see now. You can see the entire thing now. So m1 d square x1 by dt square b1 into dx by dt plus k into k1. So k1 into x1 minus x2 equal to 0. So this is the first equation. So last class I stopped here. Most of the students stopped here. Okay, that is not correct way. You have to complete the problem because previously we solved 2-3 problems. So you have to show your understanding. So now we move ahead. We go for the free body diagram of M2. Free body diagram I write here so that you can understand. Free body diagram of M2. So M2, little down, I need to draw anyway. Okay. I use this side for displacement. Displacement is x2. So whenever the displacement is not given explicitly, we have to assume. Okay. Don't say that the data is insufficient. Data is sufficient. Wherever it is needed, you need to assume the data. Okay. So this is, you can see now, free body diagram of M2. Now you can write, you refer the original diagram. You refer the original diagram and tell me what are the components connected with. You can type it in the chat box or I ask questions. What are the components connected to M2? M2. You can type your answers here. The components connected with M2. Okay, Venkateshan is the first person to answer. Good student. Okay. Group 1 says K3, K1, okay, B2. Okay. Now I ask a person. Now I am receiving answers. Jawahar, can you type your answer? Jawahar, can you type your answer or unmute yourself and answer? Jawahar can answer now. Jawahar, are you there? Jawahar, you can unmute and answer.
Jawahar. 1 and 3.
Jawahar is not answering anything. Ma'am, can you hear me, ma'am? Jawahar, he has typed now. Okay, ma'am. Okay, ma'am. Okay, you can unmute and answer or type it in the chat box. That's enough. Okay. Okay. Now I can clarify your answer. I received answers. The very first answer, Venkateshan typed the answer. M2, B2, K3. Actually, the components connected with M2 are B2, okay, K1 and K3. K3. But the opposing force, is there any applied force? Students can quickly answer. No bracket is required. Okay. Or no, is yes or no? You type yes or no. Is there any applied force? Refer the original problem and type your answer. Is there any applied force? Is there any applied force connected to M2? Quickly type yes or no. Ma'am, what is happening, ma'am?
Nothing, sir.
Jawahar, you can unmute yourself.
Sir.
Jawahar.
Hello.
Yeah.
Sir.
Unmute yourself.
Answers.
Okay, now I can you quickly say,
Unmute
is there
sir
any
பண்ணிருக்கேன்.
applied force connected to? Pardon me. Okay, we proceed further. So there is an applied force. There is an applied force with M2. So that is F of T. That is F of T. F of T is the applied force. F of T is the applied force. Okay. Or this side, I write this side. F of T is the applied force. Okay. And the other forces are Fk3. I write here. You can see Fk1, Fm2. Fm2. Fm2 is the opposing force given by the mass. Fm2 is the opposing force given by the mass. Fk1 is the opposing force given by spring K1, and Fk3 is the opposing force given by spring K3. And other side we have, it is reserved for Fb2. It is reserved for Fb2. So now you can answer, what is Fk3? We write one by one. What is Fk3? I call one by one. I call somebody. Avinash, you can unmute and answer. What is Fk3? Avinash, 202.
202.
Okay,
Avinash.
we type this answer. K3 X2. K3 X2. Exactly right. So I am very happy now. People are understanding. So Fk3 equal to K3 into X2. Okay. Fk1. Fk1. What is Fk1? I call somebody. Darshan can answer now. What is Fk1? Fk1. I check it quickly. Check it up. Sugandh is answering. Sunath. Darshan. Darshan, are you there? 205.
205.
Darshan.
Sir, he is joined just before 10 minutes, 5 minutes only, sir.
He is not there, I think.
Yes, sir.
Darshan.
Late comer.
Okay, note his name. Now
Yes,
Divine
sir.
can answer. Divine.
208. Dependent.
சொல்லுங்க சார்.
Divine. What
X1
is
into
Fk1?
X2 minus X1.
Fk.
Hello sir.
Repeat your answer. Yes,
X1
yes,
into
I'm
X2
hearing.
minus X1.
X1. Is it X1? Is it X1?
K1. K1.
K1. Oh, okay, good. K1
X2
into
minus X1.
X2 minus X1. Very good, very good. Right answer, right answer. Okay. Now I call somebody for FM2. FM2, FM2, 214. Kavin Prasad, you can answer. Kavin Prasad, you can unmute and answer.
Kavin Prasad. 214.
Yeah, somebody has typed. Well, Murugan is typing an answer. Kavin Prasad, 214. Kavin Prasad, are you there? Kavin Prasad. So we gave enough time for Kavin Prasad. Now we move to Madan. Yes, Madan, you can answer now. What is FM2? Madan,
Madan 216.
you can unmute and answer or type your answer. Madan,
He is too not available, I think so.
not available. Okay. Manikandan, yes, 217. Manikandan, yes. Yeah, yeah. Very good, very good. Thanks for unmuting yourself. What is your answer, FM2?
Sir, K2 in CSE.
FM2. My question is, what is FM2? Manikandan, you can proceed. FM2.
Sir, K1 into X1 minus X2.
No, only FM2 I want. Only FM2. F is equal to force for mass. Mass is force for mass is what is the force for mass? Anyway, he is giving a wrong answer.
Sir, D into X2 divided by dt.
See, you can refer the previous previous free body diagram for mass 1. For mass 1, we have FM1. FM1, what is FM1? You refer your note and tell me the answer. What is FM1?
Sir, FM1 K1 into X2 minus X1.
FM1. Already it is written by me. Now I can show you the answer. See here. You refer the screen and tell me. FM1 equal to, what is written? You refer the screen and tell me the answer, Manikandan. Manikandan.
Sir?
FM1.
Sir,
you refer the screen. FM1 equal to?
M1 into d square X2 divided by dt square.
dt square. So now you tell me the answer for FM2. Very similar to FM1.
M2 d2
M2
d2 M2 divided by dt
d square. Okay. X2 by
dt square.
Very good, very good. You have to follow the problem. Okay, thank you for answering, Manikandan. Thank you. Now we move next step. FB2. FB2. So FB2. Some white sound is we are hearing. FB2. FB2. What is FB2? I call somebody. You can answer. Because first we have A section student. I am asking questions always to A section students. So now I move to B section. Suji M 18237. You can answer now. What is FB2? Suji, Are you there? 18E237. Yes. Yes,
Sir,
he is present. Thank you. Thank you for unmuting yourself. Yes, what is the answer for you? Tell me the answer for FP2.
so B2 into
P2 into good. P2 into
D dx square by dt minus
dx,
dx cube by dt, sir.
not dx square. It is dx2. Your answer is right,
dx2,
but there
sir.
is a
Sorry,
slight.
sir. Dx2.
Uh, okay, no issues, no issues. Anyway, thanks for answering at least.
Thank you, sir.
dx2. Thank you, thank you. You can mute yourself. B2 into dx2 by dt minus dx3 by dt. Okay, so this is our answer. So how many forces it has? Refer the diagram and tell me how many forces it has. This side we have 1, 2, 3, 4, 5. Okay, and one is applied force. Applied force. Now we write the force balance equation. The force balance equation. Force balance equation. FM2 plus FB2 plus FK1 plus FK3 equal to F of T. Because here we have, it is not 0. Here we have applied force. The applied force is F of T. F of T. Okay. So now we need to substitute these values. Please listen. Please, some of the assignments, students, you have stopped at this point. That is not correct way. Okay. I have to see the chat box. Students, can you hear me? Am I audible? Quickly type your answer. Yes or no?
Yes, sir.
Okay. Thank you. So FM2 plus FB2 plus FK1 plus FK3 plus F of T. Okay. So now we need to substitute the values. M2 into D square X2 by dt square plus FB2 B2 into dx2 by dt minus dx3 by dt. FK1 I write here. FK1 is K1 into x2 minus x1, and the last one is FK3. So FK3 is K3 x2 equal to F of T. F of T is F of T only. Okay. So this is your equation. Okay. Well, now I'm not doing anything. We have written here. We have written everything separately. Individually, we have written. Say Fk3 equal to K3x2. Fk1 equal to K1 into x2 minus x1. Fm2 equal to M2 into T square x2 by dt square. Fb2 equal to B2 into dx2 by dt minus dx3 by dt. So Fm2 plus Fp2 plus Fk1 plus Fk3 equal to F of T. F of T. So I am substituting the values. That's all. So now we move to M3. So M3. So now quickly you can type. What are the components connected to M3? What are the components? Vegetation. Thank you for answering. Jivita is typing. Okay. K2, B2. Well, Murugan. Good. 2-1. Very good. Dharan, Kishore. Okay. Nitish, Naveen. B2, K2. Only B2, K2. I ask questions now. Thanks for answering. Now I move to A section. A section. Naga Vignesh, 1 to 4. Naga Vignesh, you can answer what are the components connected to M3. Naga Vignesh, what are the components connected to M3? The components connected to M3 are
So B2, sir.
only B2.
Sir,
No,
B2.
I will show
Sir,
you the
K2,
diagram.
sir.
See, you can see. Can you see the screen now?
Yes, sir. Yes, sir. Visible, sir.
M3 is there. What are the components connected with M3? This is my question. Very simple
Sir,
question.
B,
You refer
sir,
the
B2,
diagram and
K2,
tell
sir.
me.
B2, K2, sir.
B2, K2.
Yes,
Okay.
sir.
If you are alert, the chat box people are typing answers.
Oh,
Okay?
okay,
Okay.
sir. Okay, sir.
Okay. Thank you. Thank you. Thank you
Thank
for
you.
answering. Okay. Thank you for answering all the students. Now we move further. So the displacement I have taken it as X3. Displacement I have taken it as X3. And here you can see FK2. FK2 is the force, opposing force, and FB2 is the force. FM1 is the force. FM1 is the force. FM1, FB2. Students, you please listen now. Listen to the diagram. So are the things. Okay. Now you can quickly give your answer from the original diagram. Is there any external force connected to M3? Yes or no? Quick answer. Is there any external force connected to Rashik Rahman is answering. Nitish Naveen, Sanjay Kumar, Hariharan, Avinash. Okay. Joshua. Is there any force connected to M3? That is my question. Surya Narayanan. I call somebody. Pragadiswaran. Pragadiswaran, you can unmute and speak with me. Pragadiswaran, are you there? Madam, are you there?
Yes, sir.
Okay, ma'am, you can notice name, ma'am. Is
Okay,
not
sir.
there. Pragadiswaran.
Okay.
Rajesh Kumar. Rajesh Kumar. Rajesh Kumar.
127.
Is there any
Rajesh
force
Kumar.
up? Rashik Rahman is there. He has already given answer. Ruban, he is always giving answer. No issues. Sanjay. Sanjay, are you there today? Sanjay.
Sanjay.
Sanjay is also not there. I think.
I'm noting his name also, sir.
Okay, okay, ma'am. Silambarasan. Silambarasan, are you there? Sridhar, people are not there. Silambarasan is answering.
Yes, sir.
Sridhar is answering, but they are not unmuting. Okay, anyway, no issues. Okay, Silambarasan, is there any applied force? That is my question. The S is for, I'm calling your name, that's why you are given S, or is there any applied force? You have to clarify your answer. Silambarasan, you have to clarify your answer. Why you have typed yes? Is there any applied force with M3? Sridhar, you have typed yes. Is there any applied force with M3? Suganath is typing now. Okay. Silambarasan, he is typing, but he is not answering. I don't know why. Okay. No applied force. No applied force is right answer. Okay. Okay. Thank you. Thank you, Silambarasan. Thank you. So, okay. So now there is no applied force with M3. Now I start writing the equation FM3. You can see now. FM3 plus FB2 plus FK2 equal to 0. Equal to 0. So FM3 plus FB2 plus FK2 equal to 0. Okay, now we need to substitute the values. FM3, this is the force balance equations. Okay. Anyway, before this, we need to write this. FM3 equal to M3 into T square X3 by dt square. And FB2 is P2 into dx3, you can see now, dx3 by dt minus dx2 by dt. And FK2, you can see here, FK2. So FK2 equal to K2 into X3. K2 into X. K2, very good. Very good. Chivita is typing now. Good, good. Okay. Anyway, first we have to write this. Then only we need to write this. Okay. First we need to write this. So now we need to substitute the values. M3, T3, X3, dt square plus B2 dx3 by dt minus dx2 by dt plus k2 into x3 equal to 0. Equal to 0 here. You can see 0 here. So students, you can ask me questions now. So far I have asked questions to you. So you have any doubts now? Are you understanding? We have to move further. We solved 5 problems in the same topic. So first we started with transfer function. Okay. So make you more understanding of this concept. We come back to the basics. Okay. So now you can quickly type your answers, whether you are understanding or not. We move further. We take up one more problem. The problems in this area. Okay, slide. It is there in the slide. So are the 3 equations? Now we have given 3 equations. Are the 3 equations? This is called mathematical model of the mechanical translational system. See, people are not answering. So please answer. Can you hear me, students? Okay, okay. Okay, this is the answer for, okay, understanding or not? Okay, good. Ma'am, students are answering, ma'am. They are happy. So now we move to the slides. Kindly pin the madam's name.
Pin my name.
Yes, yes. Students, this is my...
Pin another
Pardon me,
device,
ma'am?
sir. Illa, sir. 2 device can join.
Oh, okay, ma'am. Okay, ma'am. Students, kindly respond to us. Okay. Whenever we give assignments, whenever we give MCQs, multiple choice questions in Google Forms, you have to respond it immediately. This all we consider for your marks. Okay. Everything, each and every assessment will be included for your marks. We consider everything. Don't worry, this is not, that is, everything is useful. Nothing is waste. Each and everything is useful. So don't worry, you submit everything. Everything is accounted. We put it like this. Shall we move, ma'am? The screen is shared.
Yes, sir.
Okay. So students, all of you type this question now. I call somebody and ask you to read. Adira, can you please unmute and read the question?
Yes, sir.
Yeah, you can read the question.
Determine the transfer function x2 of
Hmm.
s by f of s of the mechanical translation system shown in the figure.
Shown in figure. Okay, thank you. Thank you for responding. Thank you. Now, Joshua, can you unmute yourself? Joshua is always alert. Oh, he's there or not? Joshua? Joshua, he went somewhere, it seems. Jawahar? Jawahar, are you there?
Yes, sir.
Yes. Okay.
Yes,
Now
sir.
you can answer my question, Jawahar. How many masses are there in the system? What are they?
Sir.
How many masses are there in the given system? The screen you can
Two.
see a
Two.
diagram. Two masses.
Two.
Good, good, good. Okay. Jaykumar, you can unmute and answer. Jaykumar is there. Jaykumar is not there. Jivita, you can unmute and answer.
So, yes, sir.
Okay, okay, very good, very good. Okay. If we have in our problem, we have two masses. Then to give the to answer, please listen to me and answer the question. That is to represent this physical system, that is the mechanical translation system, using mathematical modeling, how many equations are required? The hint is we have two masses.
Two equations, sir.
Very good, very good. Thank you, thank you, thank you. You can unmute yourself. Now Kishore can answer. Kishore can answer now.
Yes,
Yes,
sir.
good, good. Yeah. What are the components connected to M1?
K1 and B1, sir.
K1 and
B1.
B1. Okay.
Yes.
Thank you. Thank you for answering. Very good. Very good.
Thank you.
Now I call somebody. Kirtivasan. Kirtivasan, you can unmute and answer. Kirtivasan, are you there? Yes. Yeah.
Yes, sir.
Is there any applied force with M1? Is there any applied
Sir,
force
yes, sir.
with M1? What is that? Okay, what is that applied force? That is my question. Simple question. You can refer the diagram and tell me the answer.
Okay.
Yeah, what is
Sir,
the applied
K1.
force? Yeah, applied force. My question is applied force.
Applied force. Sir, applied force.
What is the applied force?
M1, sir. M1.
What is M1? Then I have to ask question again.
Sir.
See,
Sir, F of T.
Kishore, Kirtivasan. I am speaking to Kirtivasan, no? Yeah. It is F of T is the right answer. F of T. So many students, Ashwin, Kishore,
Okay.
you have typed here F of T. Kishore typed the answer. Type the answer. Kirtivasan, you have to be little, that is alert. Okay?
Okay, sir. Okay, sir.
You have to sit with the system. Otherwise, you won't understand. If you don't understand this basic concepts, we cannot proceed further. Even if we proceed, you don't understand. Okay? Kindly sit with the system and work with the problems. Okay. So this is the thing. Now we move ahead. Now I call somebody. Jay Kumar, I asked question, I think. Kavin Kumar. Kavin Kumar, are you there? Kavin Kumar, you can unmute yourself now. Ma'am, can you hear my voice, ma'am?
Yes, sir.
Okay, but people are not responding. Manigandan can answer now. Manigandan G, 121. 121?
Yes, sir.
Yes. Okay. The dashpot are B12. B12 is there, no? Is connected between. Answer my question. Dashpot B12 is connected between. Manigandan, are you there?
Yes, sir. M1 and M2.
M1 between M1 and M2. Very good. Very good.
M2.
Okay. Now I have to ensure MG Bharat is there. Okay, you can unmute yourself. Thank you for answering. So 106, 106 MG Bharat is there. MG Bharat, you can unmute yourself. Yes, good. Okay. What is the displacement marked here with M1? What is the displacement?
Sir,
MG Bharat, you can answer now.
X1, sir.
X1. Exactly right. Exactly right. Thank you. Thank you.
X1, sir.
Okay, thank you. Thank you. I'm hearing you. Now, Kannan. Kannan can unmute yourself. Kannan. Kannan. Hey, Kannan, are you there? So can you hear my voice? But people are not
Yes,
answering,
sir.
not responding. I switch my camera. Okay.
I'm noting his notes.
Kannan not responding. Kavin can answer now. Kavin. Kavin, are you there? Kavin is there. You can unmute, Kavin. Kavin, you can unmute and answer my question. What are the components connected with? Kavin, you can unmute yourself. Okay.
Yes, sir.
What are the components connected with M2? What are the components connected with M2? Kavin, you can answer. Refer the diagram and answer.
Sir, B13.
Not answering. Kavin,
B13, B.
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 Your voice is not clear.
B13, B.
B13. See, it is not B13. You can zoom your screen. If you are using mobile phone, you can zoom the screen
B12.
so that you can view the diagram clearly.
Sir.
You can zoom the screen and tell me the answer.
B12.
Okay.
K2.
Next
sir.
one is
K2.
K2. Good. Okay, good.
B2.
Then B2.
B2, sir.
Good. Okay. Thank you for answering. Your answer is right. But the problem is, it is not B12. It is B12. You have to read it as B12.
Okay.
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 Okay, Kevin.
Okay.
Okay. Thank you. Thank you very much. Thank you for answering. Now, Dharanish, 107, Dharanish. Unmute yourself, Dharanish. I have to check whether your understanding level so that I can proceed further. Otherwise, At the end, I will be in trouble. Dharanish, note his name, ma'am. Dharanish is not there.
Okay, sir.
Hariharan. Hariharan, one till Hariharan.
Yes, sir.
Yeah. Okay. Now you can answer my question, Hariharan. What is the displacement associated with M2?
X2, sir.
Very good, very good. Are you understanding, Hariharan?
Yes, sir. Yes, sir.
Okay, thank you. Thank you for answering. You can mute yourself. Okay, now we proceed to the next screen. Now we proceed to the next screen. Ma'am, next screen, ma'am. Next slide. Okay. So the first step of all the problems are, to draw the free body diagram. A free body diagram. So the free body diagram, answer is given here. The free body diagram is for M1 is, you can refer the screen now. You can refer the screen. The free body diagram is drawn. So X1 is the displacement associated with M1. F of T is the force connected to M1, and FM1, FB1, FB12, FK1 are the opposing forces by the corresponding components. That is, the opposing force by M1 is FM1, the opposing force by B1 is FB1, and the opposing force by B12 is FB2, the opposing force by K1 is FK1. Okay, so now we can write the equations. FM1 equal to. So now you can see and say the answer. I call somebody. Ajay Kumar, you can answer now. You can unmute and answer. 103, Ajay Kumar is there. Ajay Kumar is not there. Ma'am, can you hear my voice?
Yes, sir. Yes, sir.
Okay, ma'am. Okay, ma'am. 104. 104,
Yes, sir.
Ashwin. Yes. So what is FM1, Ashwin?
M1 into d square x square by dt square.
Very good. Okay. You know how to write the equation, or simply you can answering from the screen?
I know, sir.
Very good. Good. Okay. You can unmute yours. Okay. FM1. FB1. So FB1 is, we have to move. Okay, we have enough time. Okay, anyway, we complete it before 12:30. 35 we complete it. Okay, so 35 we post the quiz questions. You have to answer. Everybody must submit. I verify and post the numbers in the group for both the classes. Okay, students, say yes or no. Can you hear my voice, students? Yes. Okay. So you have to answer. We never bother about wrong answers. Okay, that I will tell you. Let me clarify it. We want your answers. That's all. We want your response. Whether you are giving a right answer or wrong answer, that is the next thing. Okay. So now we move. We complete it quickly because we verified your understanding level. So FM1 equal to M1 into d square x1 by dt square. FB1 equal to B1 into dx1 by dt. FB12 is B12 d by dt into x1 minus x2. FK1 equal to FK1 equal to K1 into x1. So the sum of opposing forces. The force balance equation. Our job is to write the force balance equation. By Newton's second law. We are using Newton's second law. So FM1 plus FP1 plus FB12 plus fk1 equal to f of t. Okay. This is by Newton's second law. You should know. They never ask questions. What is Newton's second law? You need not to know Newton's second law. But we are applying Newton's second law. That you should know. Okay. If you know, nothing wrong in it. But in exam, we never ask what is Newton's second law. Okay. So, ma'am, we move to next screen, ma'am. Okay. Students can see now. So, now we come back actually because here we need to find the transfer function of the system as we have discussed. Transfer function, here I need to ask a few questions. Transfer function, I ask question, then we proceed further. There. Meenakshi Sundaram, I believe I can get the answer from Meenakshi Sundaram. Meenakshi Sundaram.
Sir.
What is the Laplace transform of, or you can answer the question, what is transfer function?
Sir, you asking
Transfer
definition,
function?
sir?
Definition. Basic definition of transfer function. Forgot?
Sir, I don't know clearly, sir, but
Yeah, you tell me what you know. No issues. We never punish students for wrong answer. We want answers, that's all.
sir, it is a function of the possible output.
Okay. Okay, thank you for answering. So Naga Vignesh can answer. Naga Vignesh, you can unmute yourself and answer now. What is transfer function?
Yes, sir.
What is transfer function? That is my question.
So transfer function, sir.
Transfer function, several times we have discussed, 2-3 times we have discussed in control system class itself, and you might have come across in some other subjects also. Very simple question.
Sir, the device is the output for each possible input, sir.
Devices output for each possible input.
Each possible input, yes, sir.
Okay, you are moving close to the answer because input and outputs are there. Ruban, can you tell me the answer? Ruban 130, Ruban. Transfer function.
The transfer function of output by input.
Output by input. Okay.
Input.
Okay. Anyway, please listen. I give you the clear definition now. Okay. So if I ask the same question again, you need to answer. Okay. So to find the transfer function, always we take zero initial condition. The zero initial condition is, please understand this. Zero initial condition is at the start of the system, nothing is there. No output. Okay. So to find the transfer function of the system, we need to have the Laplace transform. We need to have the Laplace transform. Okay. Whenever the transfer function is there, you remember efficiency. Now I call somebody. Samir, you can answer. What is efficiency? Samir, answer. What is efficiency? Samir is not there. Have you typed anything? Yes, sir. He is typing something, not able to answer. So, what is efficiency? Ruben, now he is typing the correct answer. Okay, anyway, you can remember now, machine performance. How do you find the, Samir, I modify my question. How do we find the efficiency? Machine performance is good. Okay. Performance may be one of the parameter. Efficiency may be one of the performance parameter. But how do we find the efficiency? Output by input. Ashwin has given the correct answer. Ashwin has given the correct answer. Thank you, Ashwin. Thank you. Output by input. Output by input is efficiency. Okay. Output by input is efficiency. The transfer function is slightly modified version of efficiency. Okay. Laplace transform of output by Laplace transform of input. If find output by input, it is efficiency. See, if we find Laplace transform of output by Laplace transform of input, then this will give you the transfer function. Please, students, make a note. We are discussing this second time. Okay, second time. So you should not forget in your lifetime. So Laplace transform of output by Laplace transform of input. Okay. Now we move further. Refer the screen. Refer the screen. Ma'am, move to next screen, ma'am. Next screen. Not M. Okay. Okay. Correct. So I'm taking Laplace transform of the above equation, the previous equation. M1 S square x1 of s, because there is no initial condition. There is no initial condition. The Laplace transform of M1 into d square x1 by dt square is the Laplace transform of, I ask questions. Kavian, you can unmute and answer. Kavian, are you there? Okay. So what is, okay, good. What is Laplace transform of M1 d square x1 by dt square? What is Laplace transform? Assuming zero initial condition, let us not bother about initial conditions. It is zero. You take it as zero. So what is Laplace transform of M1 into S square into, M1 into d square x1 by dt square? Able to answer? Kavian, you can unmute and answer.
Yes, sir.
Yeah. Can you hear my question?
Yes, sir.
Yeah. What is Laplace transform of M1 into d square x1 by dt square? Now I call Adira can answer once again. Adira, you can unmute and answer, ma. Adira, are you there? Students, can you hear my voice? Yes or no? Quick yes or no? Okay. Thank you. I have to ensure frequently. Okay, Ashwin. Okay, thank you. Who knows the answer? Jawahar, can you tell me the answer? What is the Laplace transform of M1 into d square x1 by dt square? Somebody? Typing answer. So Satya Seelan is typing. Satya Seelan, you can unmute and answer, Satya Seelan. Satya Seelan? 605, Satya Seelan.
Yes, sir.
Yeah. I'm not asking attendance. Simply, you read what you have typed here. That is the answer, exact answer, right answer.
M1 S squared x1 of s.
X1 of s. Very good. Thank you, Satyasilan. Thank you. Kavian, now he is giving answer. Okay, right. Thank you. Now we move further. That is f of t. If you have f of t, please remember, please write it down. If you have f of t, the transfer function of f of t is f of s. If you have x1 of t or simply x1, the transfer function is x1 of s. If you have x2 or x2 of t, the transfer function is x2 of s. Okay. And for mass, we have second order differential equation. For mass, the force equation of the mass contains second order differential equation. So if it is second order differential equation, you multiply x1 of s with s square. If it is first order, for all dashpots or damper, we have first order differential equation. For first order differential equation, you multiply with s, simply s. Okay. Don't bother about initial conditions because we consider initial conditions are 0. That is the basic definition for transfer function. Okay. Are you understanding? Okay. I assume something and proceeding further. So on taking Laplace transform of the equation, we get m1 into s square x1 of s plus b1s x1 of s plus b12s into x1 of s minus x2 of s plus k1 into x1 of s equal to f of s, equal to f of s. Okay? Is it clear? Is it clear? Okay. Okay. Kishore says yes. Dharan says yes. Sridhar says yes. So I assume I receive yes from everybody. Now you can see Madam moved to Mass 2. So after seeing the time, she has moved to Mass 2. So now we move to Mass 2. So Mass 2, please listen, please listen. Mass 2, the components connected with Mass 2 are, quickly type your answer. Somebody, if I receive one answer, I can proceed further. What are the components connected to M2? What are the components connected to M2? Students, can you hear my voice? Ma'am?
Yes, sir.
Okay, ma'am. But I receive no answer. I have a doubt
You
whether
can
I am
ask
connected
the
or not.
last one. Akash, Amitaraj, Pradeep, Prashad.
I can ask. Ma'am.
Okay, sir.
Rokesh Kumar, why you are changing your name with roll number? Rokesh Kumar, are you there? Rokesh Kumar is not there. Prasad?
Sir, yes, sir, yes, sir.
Okay, well, you change your name because we have trouble in finding you. Prasad Pradeep.
Okay, sir.
Prasad, you can answer now. What are the components connected to M2? Prasad, you can unmute yourself and answer.
Sir.
Prasad?
Yeah, Prasad.
You can unmute and answer. What are the components connected with M2? Still you are not unmuting.
Sir,
Pradeep,
B2.
Pradeep, are you there?
Sir, B2.
Prasad, you can answer now.
Sir, B2. B12.
A B12, that is not B12, it is B12. Already I have told you, people are not listening. Okay, go ahead. Go ahead with your answer.
Okay, sir.
Yeah, what are the components connected with M2?
Sir,
B2 is one
B2,
answer, B12 is other answer. What is the other component?
K2, sir.
K?
2.
K2 or K1?
Sir, K2.
Is K2?
Yes, sir.
Ma'am, kindly go back to the previous diagram. One step. Okay, right. Ma'am. Go back to the
Thank you.
original, this previous place. To the previous place, ma'am. Sir, thank you for answering.
Thank you, sir.
Oh, thank you. So K2 is K1 is the right answer. So Fm2 equal to M2 into d square x2 by dt square. Fb2 equal to B2 into dx2 by dt. Fb12 equal to B12 by dx by dt x2 minus x1. And Fk2 is K2 into, here why it is written? Ma'am, move one step further, ma'am. Slide. Move the next slide. Okay.
Yes, sir.
Now students can refer this now. Here one mistake is there. I will correct it and post it there. Here, the final answer is correct. That is, after transformation, it is correct. But here, before that, K1 x1 is there. It is K2 x2. K2 x2. After transformation, it is they have given correct answer. Okay, there is a mistake. I will correct it. Don't worry. So M2 into S square x2 of S. You refer the transform on taking Laplace transform. M2 S square x2 of S plus B2S into x2 of S plus B12 S into x2 of S minus x1 of S plus K2 into x2 of S. If it is K2 into x2 of S, there must be that is K2 into x2 equal to 0. Okay, that is a mistake that we corrected. So here they are taking x2 of S common. So x2 of S common. So x1 of S is there. So after taking Laplace transform and rearranging, you refer the from the bottom second equation. X2 of S is equal to M2 S square plus B2 B12 into S plus K2 minus B12 S into x1 of S equal to 0. So next step, last step of the screen is x2 of S. Okay, x2 of S equal to B12 S into x1 of S divided by Madam, just go back one step, ma'am. One screen. Yeah, last line. I have to do something with this. X2 of S is equal to M2 S square plus B1 plus B12 S plus K2 equal to B12 S into x1 of S. S into x1 of S. Now we move to next screen, ma'am. Okay. So now x2 of S is equal to B12 into B12 S x1 of S by denominator x2 of S in terms of x1 of S. Okay. So what we are doing in this equation, what we are doing is we are finding x2 of S in terms of x1 of S. Pure mathematics here. X2 of S equal to B12 S x2 of S by M2 S square plus B2 plus B12 S plus K2. Okay. Now we substitute this x2 of S in the first equation. Equation 2 in equation 1. Okay. So simply we substitute and find the transfer function. X1 of S. Once you know the equation, you find the unknown. That is x2 of S. X2 of S in terms of not unknown. x2 of s in terms of x1 of s, and simply you substitute x2 of s in the first equation, x2 of s in terms of x1, you substitute and rearrange it. Mere substitution and rearrangement. You get x1 of s by f of s, x1 of s by f of s. That is the transfer function, x1 of s by f of s. So this is the other side. You can see m2s square plus b2 b12s plus k2 divided by m1s square plus b1 plus b12s plus k1 m2s square plus b2 plus b12s plus k2 minus b12s whole square, b12s whole square. So this is the transfer function of the system. Ma'am, is there any slide, ma'am, further? No screen, no slide, I think. Ma'am?
Sir, one more slide is there, sir. x2 of
What is
s
there?
by f of s. So
Simply,
there we have find out x1 of s. Here we have find out x2 of s divided by f of s.
okay, okay. That is because as we have two outputs, we can have two transfer functions. We can have two transfer functions because the force is same. Please listen to me. The force is same. F of s is the Laplace transform of force. So that is the Laplace transform of input. The output is, there are two outputs. There are two outputs, x1 of s and x2 of s. So either we can have x1 of s by f of s or x2 of s by f of s. x2 of s by f of s. So previously we have substituted x1 of s in terms of x1 of s in terms of x2 of s. So here we need to substitute x2 of s in terms of x1 of s. Okay, simple rearrangement. x1 of s is given here. So if I substitute x2 of s in terms of x1 of s, all the terms which has x1 of s will be replaced with the terms x2 of s. That's all. Then simple rearrangement of this rearrangement. You can do it after the class. You can do it after the class. If you have any problem, you can ask me doubts. So x2 of s by f of s. This is also transfer function. So and in the end semester question or test questions, explicitly they will ask either x1 of s by f of s or x2 of s by f of s. If it is not asked, you find or you determine either x1 of s by f of s or x2 of s by f of s. Both are correct. Both are correct. They won't reduce any marks. Okay. So now it is 12:36. We are posting the already posted the quiz questions. You can answer. We must receive all the that is answers from all the students. Okay. Otherwise, we need to do something. We have to mark option. No other go. Simply you are attending classes, not answering any question means it is meaningless. Okay, there should be some meaning. So kindly submit, all the students submit your answers. Right, ma'am?
Yes, sir.
Yes, yes. So the Google form is posted in the chat box. Google form is posted in the chat box. So madam, she has typed that based on this quiz, attendance will be provided. So don't take much time. Before 12:45, you have to complete it. All simple questions, very basic questions. This is to check your understanding level, how you are understanding, how you are following. So you can answer now. The questions are opening correctly, able to answer. I'm not asking answer, the format I am asking. Somebody can type. Able to open the Google form? Yes. Suji types yes. Yes, Roman. Yes, Roman. You can answer. You can answer. Concentrate on answering. Answering the questions, not to my question. So if you have any doubts, you can unmute and answer. Ask. Unmute and ask. If you have any doubts, please. If you have any doubts, please unmute and ask. Don't leave from the class. 12:45 till 12:45, you have to be here with us. And 11:15, we start our class by 11:15. You must join the class at 11 o'clock, at least by 11:05. Still, some of the students are regularly coming late.
Only 70 students are there, sir, now.
Only 70 is there. Attendance is a bit low, ma'am, today. I don't know why.
So total 87, 17s are not there.
Including ourselves, it is 70, ma'am. So we have to
Okay.
subtract another
67. 67 is there, sir.
67. What is happening? See, students, if you miss the class, you cannot proceed further. So there is a gap. There is a gap. Always there is a gap. It cannot be filled immediately. You need to attend separate classes. So don't cut the classes. Weekly 2 days we have a control system class. Don't cut the classes. If you cut the class, you will be in trouble at last. Sumant Reddy, are you following the class? Understanding?
Yes, sir.
I'm not hearing you. Bit louder. Okay. If you have any doubts, please ask us.
No, sir.
Okay,
No
don't
doubt.
hesitate to ask questions. Ask questions. Don't worry. Attending classes regularly, Sumant Reddy,
Yes, sir.
because I'm seeing first time your name here.
Attending regularly, sir.
Okay, attending classes regularly.
Yes, sir.
Suman? Okay.
Have you all copied the last step? X2 of s divided by f of s. Have you all copied?
Ashwin says yes, ma'am. So next class we discuss the answers for quiz questions also. But the thing is, you need to submit the answers. So that is the concern. So without any network issue, we have completed the class today. Srinithan. Srinithan, have you submitted your forms? Srinithan, 235. He might have left, I think. He's there. Srinithan. Srinithan. Okay. Suman Reddy is there.
Sir, attending, sir.
Okay, okay, good, good. Okay, go ahead, go ahead. So next class we move to rotational systems. Okay, we have spent enough time in translational systems, rotational system. After that, we solve few problems in translation systems also. Don't worry. Okay, submit your assignment, submit your questions, forms.
So shall we wind up?
Started. Yes, ma'am. 1 minute is there, ma'am.
Okay, sir.
1 minute. 1 minute. We stay here with them
Okay, sir.
and wind up. Okay, thank you, students. Thank you.
Thank you, sir.